Hello, this video will be focusing on identifying the relationships in your data. So you have multiple different columns, numerical values, and you would like to assess the relationships within your data set. How would you approach that? And that's going to be the topic of this video. What we will do is we are going to take a look at scattered charts and try to visualize the relationships between different data columns. And we are going to take a look at correlation analysis in Excel. All right, let's get started. Let me introduce the data set first. So this is a PGA Tour golf data set, and we do have the top 200 golf players in the tournament. And we do have their information and their statistics given to us, okay? So the last 1, 2, 3, 4, 5, 6 are very generic statistics, but anything between column C and L, we are interested in digging further down to see if there are any relationships among these columns, okay? So how do we go with it? So let's take a look at, first of all, two at a time. Like, let's take a look at the age of a player and the events that this player, I think, attended in this tournament. So there are further explanations here in the comment section of these columns, what these columns might mean. So let's take a look at the scatter chart of the age and events column. All right, let's select the entire two column and then go to the insert chart, scatter chart section. I will click the first one. So yeah, this should bring up um, the relationship between the age and events column. As you can see, it picked up event on the x-axis. Guess it is the event on the x-axis and age on the y-axis. If you would like to enter axis titles, you can add axis titles here, primary and horizontally. Okay, so you can change these names if you want to, and that should be it. I think on the y-axis it put events, and on the x-axis it puts ages. Okay. All right. So, as you can see, there is a whole bunch of blank here on this spot. If this is annoying, what you can do is you can just click on the x-axis, and actually double click on the x-axis. It should bring up this setting called Format Axis. If it doesn't pop up with double click, I think once you select the X axis or Y axis, doesn't matter, you can just go ahead, right click on it, and then click on the format axis. It should bring up this setting. It gives you options. It is, as you can see, it is giving you the minimum and the maximum point. Since this whole white area is going to be blank, what I'm going to do is I'm going to tell Excel that it should start the minimum at 20. Okay, let's go ahead and do it. I hit enter. As you can see, it got rid of that white annoying blank space and then gives me a nicer scatter chart. What is the relationship between age and events here? That would be the first question that we should ask. Is, for example, age increasing with the events increasing, or is age is decreasing with events decreasing? Or is there a negatively proportional relationship here? We do see that information here. I don't think we do. I don't think we can say that age is increasing with events or events is increasing with ages, or they are decreasing together, or they are inversely proportional. We can't really say that because I think the data is if you look at the blue dots, those are randomly scattered all around the chart, right? There is not a positive trend. There is not a negative trend. I can't really tell. Another way of identifying trends is through adding a trend line. How you do it? Once you put the scatter shot together, you just need to click on any data point and then right click on the chart. It brings up this option where it says add trend line. Okay, it added my trend line like this. So it basically tells me that there is a slight negative slope here. It is indicating that as age is increasing, the events is decreasing. It might be the case, but really, really small. It gives you multiple different options to play with this trend line. If you have like an exponential relationship between these two, you could change the settings to exponential. It automatically comes out with the linear. If it is logarithmic, you can change it. If it is polynomial with multiple different orders, as you can see, you can do that as well. If it is a power series, you can also arrange it. Moving average is not going to work out for us because it's not a time series data, but all bunch of cool different settings that will be brought by Excel. Another nice thing is that you can actually see the relationship, the function of this trend line. If you click on display equation on the chart and display R square value on the chart, and then take them somewhere here, it basically tells me that Y, on this case, it is the events, is equal to minus 0.0836 times X, right? X here on the X-axis is the ages, plus 25.791, all right? This is the function of this equation. Of course, it is going to give you a value on this line. For example, if you plug in 45, it's going to give you right this point as an event. Of course, this is an approximation. And it's not really a good approximation because, as you can see, the R square value is very, very small. R square is any value between 0 and 1. So if your R square value is closer to 1, it means that your X is a good representation of your Y, right? For example, if your R square value was 1 here, you would just only see the points on this function line or trend line, but that's not the case here, okay? All right, this is just between ages and events, and I did a bunch of other scatter plots here. I'm not going to do them again, but it is literally the same thing, selecting two columns, clicking insert and scatter chart, and it's going to bring you up this nice scatter chart. So it looks like there's a positive trend here and there's a negative trend here. So the negative trend is between yards drive versus driving accuracy, right? That makes sense, right? There is a if if the driving accuracy is increasing, the yards drive is decreasing, right? So that's just to make sure. You can add the trend line and you can get your equation on the chart. And that looks like it is what's going on, right? And here, get your trend line and get your function up in there. Okay. As you can see, R square value is very high here. It is 0.78. It is very close to, well, not really close, but closer to 1. And it is basically telling me that once the rounds is increasing, cuts made is also increasing, right? That's one thing that we could identify. So this is positive correlation, right? The correlation coefficient is going to be on the plus side here. And this is a negative correlation because one is increasing, the other one is decreasing. The correlation coefficient between these two is going to be negative. All right, so speaking of correlation, it's also another measure that is going to tell us about the relationship between two different data set or data arrays. And the way that you can calculate it in Excel is very simple. If, for example, you are interested in finding the correlation coefficient between age and events, by the way, I'm only looking at 2017 data here, and there are a bunch of other data sets here. If you're interested in getting together the correlation coefficient between age and events, what you need to do is to come over here. The formula is already here, and I will type it in Excel. um, Corel function, and it gives you the option to select your arrays, two arrays that you're interested in. You cannot select more than two or less than two. It has to be two. Um, and then let's do that. And then here. So the second array is going to be the events. Enter. As you can see now, it is also giving me that the correlation between age and events is negative, but it is very close to 0. So correlation coefficient can be any value between -1 and 0. Okay, if you have any negative correlation between two things. So if it is closer to -1, it means that the negative correlation is very strong, right? If it is close to 0, it means that, oh, there is a negative correlation between the two, but it's not really that strong, right? I would say anything less than 0.5 or maybe anything greater than minus 0.5 is not strong correlation. Well, depending on the application, for sure, depending on the domain that you are interested in. On the other side, you could have positive correlation values too, but those numbers should be between 0 and 1. So anything closer to 1 means there is a positive correlation between the two. Um, let's write it down for, we obviously saw it here between rounds and cuts made. If you would like to calculate the correlation coefficient between rounds and cuts made, all you have to do is to, again, tell Excel to find it. Rounds, let's select that. It's over here. Okay, and cuts made right over here. As you can see, the correlation coefficient is very close to 1. It is 0.8888, right? So it means that there is a positive correlation between rounds and cuts made. And there is a strong negative correlation between, and we saw it on the chart, between yards drive and driving accuracy. Yards driving accuracy. Let's calculate that. Okay, yards drive. And driving accuracy. Okay, so yeah, it is actually negative 0.7, and that's a strong negative correlation between these two data columns. So yards drive and driving accuracy, if one is increasing, the other one is decreasing for sure, right? You can tell this from the chart and from the correlation coefficient. Well, as you can see, there are a bunch of columns here, right? And pairwise comparison of these two would require you to get the entire set of correlation coefficients together. You could put it up in an Excel like the Corel function, or you could use Excel's data analysis toolpath. Right? So let's do it. Let's go to data analysis, okay? And then again, one more time, if your data analysis toolpath is not activated, make sure to watch the videos that I posted at the very beginning of this class. And if you go to data tab, you should be able to see on the top right somewhere, doesn't matter whether it's PC or Mac, you should be able to see data analysis option. Here, click on correlation, okay? I did this already, so let me show you one more time. So it says input range. I'm interested in finding the correlation between all these stuff, starting from age to send save percentage, right? And I'm putting command and shift and bottom arrow key on my keyboard to select everything in this table. And make sure that you select columns as your group by variable. and then make sure that you have a checkbox here for the labels in the first row. It's going to tell Excel that the first row is including the labels, not numbers. An output range, what I will do, I will come over here and I am going to put my table here, right? Oh, I messed up the, I messed up the selection. So I will do it one more time. So whenever it is here, I'm interested in the values between age and sensitive percentages. I will select the entire data. For the output range, I am going to have my correlation table starting somewhere here. Okay, and I hit OK. As you can see, Excel gave me the correlation table, and its bottom triangle is filled up because correlation is symmetric. So the way that you read it is this. So the correlation between age and age, well, basically the same column is 1. So correlation between events and events is 1. Well, they are directly positively correlated because it's the same data, right? But anything that is non-identical, for example, events and age, it gave you a correlation coefficient of minus 0.084, and that's the value that we also found earlier. There is also another pairwise events and age here, right? So, well, if it is if this is the correlation coefficient between age and event, it should be the same one here, right? Similarly, in cuts made an age, it is negative 0.10, and I do have cuts made an age here, right? It should be also this same number. Well, that's why Excel is leaving the upper triangle empty, and then all you need is the bottom triangle or upper triangle, it doesn't matter. But for some reason, Excel gives you the correlation matrix table with the bottom triangle filled in. Well, it is hard to see the numbers like this, right? The one quick way to make sure that you could take a good visual on these numbers is conditional formatting, right? While you are under data, once you select the entire matrix, what you can do is go to looking for conditional formatting somewhere in the home tab, conditional formatting, color scales. You could have a bunch of different colors. I'm going to pick green, yellow, red colors, right? That's perfect. So what it tells me that if your number is closer to 1, it is going to make it greenish, right? If it is 1, it is making them green. But for example, there's also positive relation between events and rounds. It made it very close to green, the color itself, right? And if it is negative, it is going to make it closer to the red. So the strongest negative correlation that I see here is between yards drive and driving accuracy. Is that why didn't I get the same number here? Yards drive and driving accuracy. Yards drive and driving accuracy. I should have. Let me see. H2. Oh, okay. This is missing. So it only picked up H2 through H34. I think there's a missing value. That's why it happened. So let's make sure that we select the entire table. Let's go back. Yards drive. Okay, we keep going. We keep going. There are lots of empty cells here. That's why my selection didn't work. What I can do, oh, I think I'll have to do manual here, manual work here. All right, I'll just select them manually. Okay, it's not too much. 200 and comma here. And I will hit enter. All right, there you go. Now I can see that those two numbers match. So the strongest negative correlation is between yards drive and driving accuracy, and the strongest positive correlation is between the events and rounds. Okay, that's one quick thing that you could use to identify initial relationships between different elements of your data sets. Okay, this is something that I use very often. If you would like to change the conditional formatting, you can come over here. You could do many different things, but I like color scales here. Let's change it to all green, or let's change it to pinkish, right? Or let's change it to something else. But usually green, red, and yellow are used, the themes used in this kind of analysis. Well, thank you so much for watching. I'll see you on the next video.